Hi guys, this is Mrs. Nell, hoping that you are all well. Today we have Circle C, and as you see Circle C, there are some things that you may not recognize. One of them is called a chord. A chord is a segment that goes through the circle, but not necessarily at the center. We have a secant that is a line that goes through the circle at 2 points and does not go through the center. We have a line called a tangent that touches the outside of the circle in one spot called the point of tangency. Here you see the relationship between the radius and the diameter. Congruent circles are two circles if and only if they have congruent radii. Concentric circles are in the same plane and they are inside of one another and they have the same center. As you see, then we have tangent circles. Tangent circles are coplanar and they intersect at one point. They can be on the outside or they can be on the inside of one another. You can see that circles can have 0 common tangent lines, 1 common external tangent. Some of them both have external and internal common tangents. The green are the internal, the red are the external. Now it's your turn. Sketch these and draw your lines of tangency. Pause and then start it again to see the next page. Now this time, identify each part of the circle. Pause the video at this time, and when you're ready, you can continue the video. Let's look at these two circles. They overlap one another. The diameter of circle S is 30 units. The diameter of R is 20 units. And DS is 9 units. You need to find CD. Theorem 1. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of that circle at its endpoint on the circle. This is called tangent line to circle theorem. Let's look at this. What do you notice about the shape created by the lines? They form a right triangle, so we can use the Pythagorean theorem. Notice here we have a triangle, and we have one side of the triangle is R, another side is 12, and CA is R to the edge of the circle, and 8 from the outside of the circle to A. We need to find the value of the variable. So when we set it up, we know that we have a squared plus b squared equals c squared. Well, we have 12 squared plus r squared, but our c squared is the quantity of r plus 8 squared. So now we have to take r plus 8 times r plus 8. So what that gives me is r squared plus 16r plus 64. Now I need to get everything on one side of the equal sign, meaning I have to subtract r squared from both sides. And that means that my r squareds are going to cancel one another out, leaving me with 144 plus 16r plus 64. If I move the 64, I get 80, and 80 divided by 16 is 5, so r equals 5. Okay, this time you try this one on your own. Pause the video, and when you're done, you can restart it. This is our second theorem of the day. It's called the external tangent congruence theorem. Tangent segments from a common external point are congruent. So in order for me to find x for this one, I know that 3x plus 4 is equal to 28. And then I would go ahead and solve for x. That's it for today. You have an assignment on Big Ideas. It will be due at the end of the week, so get them done as soon as you can and check back tomorrow for more.